Hello everyone, I welcome you all to this channel, and in this video we are going to discuss a very important topic of the metal forming chapter, that is the extrusion, right? So basically in this video we are going to discuss about three important aspects. That is, first of all, we will see what is the basic concept of extrusion. We will also see what are the formulas and what are the procedure to solve any kind of questions coming in the exams, right? We will see all of this in a great detail, and also we will see what are the different types of extrusion process. Okay, so this will be our three aspects in this video. So first of all, if we discuss about the basics of extrusion, as you can see, here is a closed die container, okay, inside which here is billet, and here is a ram through which we are giving force, right? And we are getting our desired output of the extruded product from this hole. It is passing through this hole, and finally we are getting our extruded product like this. So again I am explaining, here it is a closed die container, inside it is a billet, right? So it is a billet, and here it is the ram. This ram is giving force to this billet, and this billet is passing through this tiny hole, and through this hole we are getting our extruded product. So extruded product of this is of the same material as of the billet, right? So initially the diameter of the billet was d0, and after extrusion the diameter of this extruded product is becoming df. Okay, and we are giving force to this ram, and the force is transferring from this ram to this billet, and therefore it is passing through this hole, and finally we are getting our extruded product. So just remember this thing, that what is an extrusion ratio? It is denoted by R. So here R is equals to A naught by AF, where A naught is the final area, A naught is the initial area, which we can get by pi by 4 into d naught square, or the initial diameter square, and AF is the final area, which we can get by pi by 4 into df square, that is the final diameter square. So this is the extrusion ratio, and one more important thing is this 2 alpha. It is the angle, it is known as the diangle, and alpha will be therefore half of the diangle. So this is all. I think the basics of the extrusion is clear to you, and now we are going to see what are the different formulas which are required to solve any kind of questions coming in the exam. Now as you can see here, the first formula is the drawing stress. So how to find this drawing stress? That we are giving a force and we are drawing this extruded product. So what will be the drawing stress? So just remember that drawing stress is denoted by sigma d, and it is equals to sigma y, that is nothing but the yield stress, which will be generally given in the question. So yield stress into ln, that is the log of a naught by af, which is also known as the extrusion ratio, and it is given by r. So just remember that drawing stress is equals to sigma y into ln a naught by af. Okay, and please remember that this drawing stress is when we are neglecting the friction. Here is no friction is involving in this case. If there is friction given in the question, then this formula will not work, but most of the time the questions will given that it is a frictionless case. Okay, so for a frictionless case where no friction is involving, drawing stress is equals to sigma y into ln into a naught by af, where a naught by af we have already seen it is given by r, and it is known as the extrusion ratio, where sigma y is the yield stress. So please remember this. And we know that what is force is nothing but stress into area. So here we have taken the initial area, because the force is giving force we are providing in the initial state, that is we are providing the force through the ram, and which is in this side, that is the initial diameter side. So therefore we are taking force is equals to sigma d into initial area. So sigma d we have already calculated, we will just put the value over here into pi by 4 into d naught square, or the initial diameter square. So that is which we have written here, a naught equals to initial area, and d naught equals to 4. So d naught equals to initial dia, right? So please remember this. And now here is the formula. If in question it is giving, or it is mentioning the term friction, okay, so at that case the coefficient of friction will be given in the question. So if it is given in the question, then you have to solve by considering the friction also. So at that case, when we are considering friction, the sigma d or the drawing stress value will be equals to sigma y into 1 plus b 1 plus beta divided by beta into a naught by af to the power beta minus 1. Now the only new term here is the beta. So please remember that beta is equals to mu into cot alpha, where mu equals to coefficient of friction, which will be always given in the question, and alpha is nothing but the half the diangle. We have seen in the diagram that 2 alpha is equals to the diangle. So we will just calculate, or we will just find the half diangle, and we will just put the alpha value over here, and we will find the beta value, and we will put in the formula, and we can easily find the sigma d or the drawing stress value. So please remember that whenever friction is given in the question, we have to use this formula, but most of the time the question will be frictionless, so we will use the above formula, drawing stress. But you have to remember these two formulas. Okay, now as you know that force is equals to sigma d into pi by 4 into d naught square. So if friction is given, so take the drawing stress value from here. If friction is not given, then assume it to be frictionless and find the sigma d value from here, and simply put this equation in the force value, and we can also find the force value, right? So now only one formula is remaining, which is the most important formula. Many times questions are seen from this. Suppose in question sigma y yield stress is not given, and you are directly asking to find the value of F or the force. Then what will you do? So okay, so remember this formula, that force is equals to K into A naught, where K is the extrusion ratio. If extrusion ratio is given in the question, that is K, so force equals to K into A naught into ln A naught by A. So please remember this formula. This is the most important formula. Many times questions are seen from this. So force equals to K into A naught into ln A naught by AF, right? So remember this formula. This is very important. So here is the different types of extrusion, right? So as you can see, there are four kinds of extrusion mainly. So one is the direct extrusion. The example which I have seen in this video is the direct extrusion, where we are giving force from one side and we are getting our extruded product from the different side. Okay, so I would like to show you that. So here is our direct extrusion. We are giving or providing the force from one side, and we are getting our extruded product from this side. So this is the example of a direct extrusion. And suppose it is a case where we are giving the force from this side, and we are getting the extruded product from this side only, from the same side. Then this kind of extrusion will be called as the backward extrusion. So that was our second example. Okay, so that is the backward extrusion or the indirect extrusion, where we are giving the force from the same side as that of where we are getting our extruded product. And if we are giving the force from one side and we are getting our extruded product from the different side, that kind of extrusion is known as the direct extrusion. So as this video is getting longer, so I am not explaining in details, and I will obviously make some different videos to explain all of this. Now in short, I have discussed you that what is direct extrusion, what is indirect extrusion, and now what is the hydrostatic extrusion. Just remember that in between the die and the extruded, in between the die and closed die container, if there is some kind of fluid is there or some kind of oil is there, then that case or that kind of extrusion is known as the hydrostatic extrusion. And if some impact load is we are using some impact load to find our extruded product or to get our extruded product, then that kind of extrusion is known as the impact extrusion. Although it is not a detailed or a great explanation of this extruded product. Okay, so I will definitely make one different video where I will be explaining all these extrusion in a great detail. So that was all about the extrusion for today, and we have discussed the simple what is the basic concept and formulas. The formulas will be more than enough to solve any kind of questions coming in the exam. And we've also discussed a bit about the types of extrusion, right? So I hope this video is helpful for you, and if you like this video, please click on the like button and please subscribe to this channel. Okay, thank you.